Okay, we were talking about the problems on section 1.3 where we dealt with trigonometric functions of an arbitrary angle. We said the idea is to locate a point on the terminal side of the angle, call it xy, find out the positive distance from the origin. Remember that if you were in the first quadrant, y would be the side opposite of the angle theta, and x would have been the adjacent one. And then you write your trig functions. So sine of theta becomes opposite to the hypotenuse, and the cosine of theta is going to be adjacent to the hypotenuse, and tangent of theta becomes opposite to the adjacent, and the reciprocal of these things, cosecant of theta, secant of theta, and then cotangent of theta, same style. So these are our new definitions. How do the problems come about related to these things? For example, I'll say pick problem 30. It says the terminal side of angle theta is in standard position, lies in the given line in the given quadrant. Find the trig functions of that angle. So problem 30 says consider the line 4x plus y equal to 0. Imagine that line and pick the section of this line that happens to be in quadrant 2. Then go ahead and find the 6 trig functions of the angle in standard position that is made by this line. What does this mean? Let's go ahead and draw this line. We have our coordinate system. If you wish to convert this thing to the format you are used to in high school, like y equal to mx, I take the 4x to the other side. So the equation of line becomes y equal to minus 4x. What kind of a slope does it have? Slope of it is minus 4. Is that right? So that means for every step to the right, we are going to fall 4 steps. So it's a kind of a steep line going in this direction, and here is a continuation of the same line going the other direction. So this is graph of y equal to minus 4x, or if you want to write in the original format, 4x plus y equal to 0. So that's our line. Now it's talking about the angle in standard position. What does it mean, standard position? Where do we start? Standard position starts on the x-axis, so that's the beginning of standard position, and this is essentially telling you where to stop. This is when you hit the line in quadrant 2, stop. Don't keep going to quadrant 4. So that is what this information is used for. So this is the angle theta. On the test I might ask you to actually show the angle theta. Next, we want to find these trig functions. Well, to find the trig function, I need a point on the line with coordinates. For example, I can come here and say, if I want to be in quadrant 2, I should pick a negative x, such as what? Let's pick a nice number. What's a good number to pick? Negative 1, negative or whatever. So let's keep it small numbers. Negative 1 gives me a y of what? 4. So this is going to give me a coordinate of minus 1 and 4. So that was a crucial step. First of all, what x should I pick? I want to be in this quadrant, so my x has to be negative. I keep my numbers reasonable so that everything turns out to be integer if possible, or just keep a small number. So x, I kept minus 1, my y became 4. I'm almost ready. X minus 1, y 4. All that I need to figure out is r. What is my r? If you wish to think about it, here is your right triangle. dimensions of it, 1 and 4, the hypotenuse becomes by the Pythagorean theorem. So you say R is always square root of x squared plus y squared. 1 squared plus 14 squared is 17. X is 1 plus 4 squared is 17. And so this becomes square root of 17. This is okay. Now we are all ready. Say sine of theta. If you wish to think about it like this is kind of brother of theta, we are going to talk about as a reference angle later on. This is going to be the opposite of it. So that is 4 over r. Cosine of theta adjacent is minus 1 or x. Tangent is going to be the opposite over adjacent, or y over x. And then the other ones, so this one, to keep ourselves looking a little bit civilized, we write it as just minus 4. These are good enough answers as they are. If you want to rationalize them, that's also fine. You multiply them by square root of 17. That's just to show you we could do this thing. It's not the essential step. And then that's all the text is asking for. Of course, if you were asked to figure out the other functions, you go ahead and get the reciprocal of these things, and then you're all set. Okay, so that was problem 29. Let's move on to some other problem. Yes? Say it again. Why is it? Because of the well, you get your r from, say, x squared minus 1 squared plus 4 squared. So that becomes 1 plus 16. That becomes 17. So think about this right triangle. One side of it is 1. One side of it is 4. And the other side is going to be square root of 17. Is that right? The only thing you have to watch out for is the plus or minuses of these x or y coordinate. That is the catch in all of the problems in this section. You want to get those things wrong. Okay, we were going to go take a look at some other problems, more or less same type. So you make sure you do at least one problem from each type of these things. If you are short of time and something like that, you do minimum of one from each type. If you are a little bit rusty on that, you cannot figure out plus and minuses, you try to do a couple of more until everything is fine. So let's move on to say 38. It says, I give you a specification of an angle. Sine of theta happens to be minus 5 over 13. And I tell you that the terminal side of this angle, the book just says a function value and a quadrant are given. What that means is that the terminal side of that angle happens to be in the quadrant that is given. So here it says quadrant 3. Okay, we are specifying an angle by giving a trig function of it and a quadrant of the terminal side of the angle. Question, first of all, let me add a little bit to this problem. It says graphed angle. As far as I'm concerned, that's the most crucial part. That's perhaps the thing that might stay with you. The rest of these identities, unless you constantly use them, you lose them right away. So, graphed angle, that much we should expect. What do you think I should do? Minus 5 over 13. What kind of a specification can you give for me? First of all, well, it is already giving you a hint which quadrant to go to, 3. So what should I do? Suppose you want to tell me when to stop. What was sine? Sine is y over r. So when you see 5 over 13, what kind of a clues do you get out of that? Who's 5, who's 13? So going down 5 is going to take care of this minus 5 here. So there was some angle here in quadrant 3. So we had some angle that was like this. We had picked up some point on it and dropped the perpendicular. This turned out to be, the y of our problem turned out to be minus 5, and r of our problem turned out to be what? Remember, sine is a ratio of opposite to the hypotenuse, but in general it's going to be y over the distance. So if I have minus 5 over 13, I am going to identify the number in numerator plus any sign I might have with my r, with my y, and the denominator is going to be the value of r. So let's go back to this problem. So I have this to be minus 5, and the radius or the hypotenuse is supposed to be what? 13. So if I was dealing with this angle, the sine of it would have been y over r, which is minus 5 over 13. What we want is, of course, to graph the angle. Here I graph the angle. Then, well, we want the other trig functions. At the minimum, we want cosine of theta, tangent of theta, and perhaps the rest of them. So we are given the sine. Then we want cosecant, secant, and cotangent. I pair them up. Sine is given. We want to find the others. Okay. How do you handle these problems? You go ahead and focus on this triangle. For the moment, throw away the positive negatives, and let's just focus on the dimensions. If this is 13, this is 5, how do I find the red piece? So let's separate the problem here. I have a right triangle like this. Hypotenuse of it 13. One leg of it is 5. How long is the other leg? It's a famous triangle, or you use the Pythagorean formula. So say, okay, this is a piece I don't know. X squared plus 5 squared has to be 13 squared. This is 25. What's 13 squared? That you should know by memory. I've seen it quite often. So x squared becomes 169 minus 25, which is 144, which is again a famous number. And x is going to be plus or minus 12 out of this. Well, if you were dealing with arbitrary, a triangle, this is going to be 12. But in this picture, I am in the third quadrant. What kind of x should I allocate here? Okay, so these problems heavily hinge on correct designation of these signs and where you happen to be in these quadrants. That is biggest issue here. So again, like if you are in geometry class, you're just starting your geometry, everything is a positive quantity. You solve these things, and when you get your x, you just say 12. But here you have to look at the picture, say, in my picture, where do I happen to be? I happen to be on this side, so I'm at minus 12. Okay, we are essentially done with 80% of the problem. All that we have to do is to remember the 6 trig formulas. For cosine, what should I write? Cosine is the ratio of x to r. So it's going to be, what did you say? Negative 12 over 13.
How do you know which one is opposite and which one is adjacent?
It's going to be a little bit, that's why we got out of that convention of opposite adjacent stuff, because it's kind of hard to explain it. So we say tangent is ratio of y to x. You have new set of definitions to remember. But let me teach you a way of cheating your way to this. You say there is a concept of reference angle that I'm going to mention briefly. Reference angle of an angle is the angle made between its terminal side and positive or negative side of the x-axis. So this is going to be the reference angle. We are going to show it by theta prime. I'm going to explain it again later, but right now briefly. Any angle that you have, any of these unfamiliar angle, they come with a kind of a sister angle or brother angle. We refer to it as a reference angle. The reference angle becomes this theta prime. Now, what is this one? Yeah, theta prime. When we want to find the trig functions of an angle, we essentially going to refer to this reference angle. So if you want to write something about theta, you can come and write it about theta prime. But that's a rather non-standard way of going about it. We have just changed the definition. We have for tangent, for example, we had the ratio of which two numbers? Tangent y to x. So if you wish, just write this and draw this thing in the first quadrant. Remind yourself what the definitions are based on what you remembered from high school. Like sine is opposite to hypotenuse, but opposite now is called y, hypotenuse called r. Tangent, opposite to adjacent, which is now y over x, and so on. Either remember those or come here and say the same thing about the reference angle. So suppose I want to write tangent. Which two numbers should I divide? What's the opposite of this? Minus 5. What's the adjacent of it? Minus 12. So what's the ratio of minus 5 to minus 12? It is expected that you clean this up or not leave it like that. 512. Okay? So y to x, with a bit of a roundabout interpretation, you can still say opposite to the adjacent. But somehow it's hard to fit that huge angle in any triangle. So you have to convert it to something else. We convert it to the so-called reference angle, which I'll mention again. Cosecant. Once you have these things, instead of struggling with the definitions, you just do what? Turn these fractions upside down. Is that right? So okay. Now we kind of jumped the gun by talking about this thing in this context, but let's go ahead and officially talk about what's a reference angle. Well, we noticed that we have this dilemma that in high school we get used to acute angles for right triangle, and now we have to live with these arbitrary angles. We see that there is a connection between the two of them, and we want to make that connection kind of official. What do we do? So, okay, go ahead, draw your coordinate system. This arbitrary angle that you're talking about, well, if it is in the first quadrant, your reference angle is just the angle between that terminal side and the positive side of the x-axis. What if I was in the second quadrant? Suppose this was my angle. That's not part of a right triangle anymore. What do? I define a reference angle for it, which is between the terminal side and the negative side of the x-axis. This is going to be the reference angle. What if I was in the third quadrant? What if the angle terminated in the third quadrant? So in this case, say some angle, perhaps you might have turned around several times and stopped there. So what if my angle was like this? We say, well, the reference angle of it is between the terminal side and the closest edge of this x-axis. So that's going to be my theta prime. So I'm not going to go from here all the way there and end up with another huge angle to deal with. No, we always define the reference angle to be an acute angle. It's an acute angle that is made between the terminal side and x-axis. It's always between 0 and 90 degrees. Is a positive quantity. It is an acute angle. It's an acute angle between terminal side and positive or negative side of the x-axis. Okay. So if you are in the first quadrant, no problem. That's just same as your reference angle. If you are what if you are in the fourth quadrant? What do? Sorry, this is, say, your angle theta, or perhaps it was a negative angle theta. Either way, the reference angle we choose for this thing is a positive quantity. It's between 0 and 90 degrees. So what you are picking, we are not going to say we are going in the negative direction, so theta prime is negative. No, we think about it pure geometrical term. What's the angle between these two rays? It's a positive angle between 0 and 90. So again, in this case, if I were given, if this was my theta prime will be the same thing. If this was my theta prime would be the same thing. Here, if this was my theta prime would be the same thing. So theta prime is a positive angle between 0 and 90 degrees that is made between the terminal side and the x-axis. We never assign a negative sign to it, and it is never above 90 or below 0. So keep that in mind. Let's practice this thing in some example problems. See how we are supposed to make use of this. Such as, say, problem 39. It says, consider the question of answering cosine of 150 degrees. Figure out the reference angle and presumably use that to give your answers with respect to what the value of the function is going to be, if it happens to be exact answer. Okay, 150, which quadrant is it? So it's the second quadrant, so 150 is 30 degrees short of making it half phase. So the 150, if this is my theta prime is what? How much is left to go? 30 degrees. The use of reference angle is that the trig functions of any angle are equal to plus or minus the trig functions of its reference angle. And of course, we are left with the difficult task of figuring out is it a plus or minus. So, any trig function of any angle is equal to plus or minus the same trig function of its reference angle. And then we are going to figure out, for example, in this case, let's go back to this situation, elementary trigonometry. Suppose you had this angle of 30. Suppose I ask you what is cosine of it. But by now we are supposed to remember cosine of 30 degree from an acute triangle. What is that going to be? We were supposed to memorize this dimensions of this triangle, which were what? 1, 2, and radical 3. Is that right? So cosine of 30 becomes what? Adjacent to hypotenuse, which is radical 3 over 2. Okay. Now the question is, how is that going to help me find out cosine of 150? Cosine of 150 is going to be x over r. Now you have to be clear and fast about this thing. Would it be positive or negative? It's going to be negative. Remember, cosine is a ratio of x to r. So if I am here in the second quadrant, my x is negative. In the second quadrant, x is negative. I'm dividing it by r. So my cosine has to be a negative quantity. What that tells me is that my answer is negative cosine of 30, which makes it negative radical 3 over 2. So let's write this thing down. Trig function of an arbitrary angle is equal to same trig function of its reference angle, except that we have a price to pay. We don't know, or we need to figure out from the case, is it plus or is it minus? This is the issue that needs to be figured out. So how do you help yourself there? In each particular case, you can just talk your way to an answer. You remember, cosine of theta was x over r. You say, okay, I'm in second quadrant. So what is x in second quadrant? X is negative in second quadrant. How about r? R is always positive. So the cosine I'm searching for is a negative quantity. So if I was in second quadrant, I would have chosen this negative angle, negative sign here. Let's go ahead, try something else. Suppose I ask you cosine of, say, 330 degrees. Which quadrant do I happen to be? 330. How much left to make it to the x-axis? Tell me where to stop. Do I stop here? No. This is 270, so I have to pass. I end up in which quadrant? Yeah, fourth quadrant. So this is 330. How much am I short of making a full circle? Okay, my picture is not good enough. So I'm left 30 more degrees to go. So I say cosine of 330 is equal to cosine of its reference angle, except that I have to figure out, is it positive or negative? I say in fourth quadrant, cosine being x over r, what is x in the fourth quadrant? in quadrant 4, x is positive. Let me write it out. X is positive. So cosine of 330 has to be positive. I'm going to pick up the positive sign here. So it's all going to go away. And I have, which just right now we found out cosine of 30 degrees was radical 3 over 2. So this teaches us it might be good to know what is the plus or minus of each trig function in each quadrant. So let's go ahead and do that. So let's see. Here are 4 quadrants. Quadrant 1 is the easiest because all trig functions are positive, so there's no fighting over there. In second quadrant, let's just write down who's negative so it doesn't get crowded. Who is negative in this? So let's remember, x is the only thing that is negative here. Who is negative here? X and y are negative, and here, so y is the only thing that's negative. So if x is negative, of all trig functions that we have, who is, well, let's go through all 6 of them. Let me write them down here again for you. Sine of theta was x over r, excuse me, repeating so much. Let's just talk about these 3 because the reciprocals have the same plus or minus that these guys do. So let's come back here. Who is negative? Remember, sine is y over r. Let me write everything here. X negative. Where does x showing here? X. So cosine is negative. How about tangent? Make room here. We write down all of them. So sine is positive. Cosine, x over r is going to be negative. Tangent, y over x, 1 positive, 1 negative. I'm going to get what kind of a ratio? Negative. Let's go to the, so this is quadrant 2. Quadrant 3. Both of them are negative. So what happens to the sine? Cosine, tangent. Tangent is a ratio of negative to negative, so I'm going to get positive. Coming to 4th quadrant. So sine is going to be is y over r, that's negative. Cosine, x over r is positive. Tangent is going to be negative. Here, of course, everything is positive. So this is the plus or minus of the trig functions per quadrant. So you can always say cosine of an angle that ends up in the second quadrant is negative of its reference angle cosine. Tangent of an angle that happens to be in second quadrant is going to be negative of tangent of its reference angle, and so on. So these are the plus or minuses that we are going to use in front of our function. This is going to be our reference angle, and we are going to decide our final answer based on combination of both of them. So let's do maybe a couple of these problems. Suppose I ask you to figure out, here's problem 41. Tangent of minus 135. Minus 135, where do I end up at? 90, 45 more to go. Here is minus 135. Okay, minus meant going this way. What's a reference angle? Reference angle is going to be 45. So this is going to be, the question is, should I put plus or minus here? In the third quadrant, tangent was positive. So this is going to become positive. How so? Tangent was positive. So I borrow that positive sign. That's the sign that comes here. So reference angle, and this is the sign that comes from that table we had on the previous page. So what was tangent of 45? You have to remember that from 45-degree triangle. If this is 45, what are the ratios here? 1 to 1 to radical 2. So tangent of 45 is just 1. So that's how you answer that question. Okay, so you do the rest of the problems of section 1-3, and you're going to have a quiz on Monday and a test on Monday following this Monday.